Hello and welcome. Welcome once again to Battery Technologies monthly roundtable of what is happening of importance in the battery industry as seen in the media. Um, every month, myself, Mike Anderson, the editor in chief of Battery Technology, is joined by senior editor Maria Guerra of Battery
Yeah.
Technology, and our longtime friend Charlie Parker of Ratel Consulting to look at these matters. It's worth mentioning just for a moment here that this is the travel episode because each of our articles are based on travel that each of us did to a different event. So take for summer vacation travel, I guess that makes sense. Maria, what have you got for us?
So I was in San Francisco for a GM Empower event. They made several announcements about energy technologies. One of them was about GM betting on sodium ion batteries. Just like Ford, GM is also investing in sodium ion batteries, but for the best market for the battery energy storage systems. The GM's VP of Battery and Sustainability, Kurt Kelty, he said that they're pretty sure that for every application there is a specific type of battery chemistry, and they believe that sodium ion batteries are a perfect match for best applications. GM is developing sodium ion batteries domestically in partnership with Peak Energy, an American energy technology company, and they are going to design and develop the cells at the Michigan Battery Labs that they have, and they plan to deliver the first mass production of the cells by early 2028.
Okay.
I believe that, well, they mentioned this also, but sodium ion batteries are often offer several advantages over lithium ion batteries. One of them being that they operate better across a wider temperature range, reducing the need for complex HVAC systems, which lower production costs. And also, sodium is a widely available material and better for a battery supply chain resilience. So that's it from me.
That's great. That's great. Yeah. The cost thing. Just today, as I was putting together our headlines column, Car News China reports that now they have there is sodium ion batteries in production that have pretty much cost parity with
Mm,
LFP. And that's going to be make that's going to make a big difference in coming years. So
yeah.
excellent, excellent. Yeah. All right. Great. Charlie, what do you got?
Okay, so I attended the Defense Power and Energy Conference sponsored by Military Power Sources Consortium in late June. So I selected a defense story that will be potentially impactful to the domestic battery industry. War.gov released a press release on the drone dominance program. It's now completed its first major order cycle with 30,000 drones purchased, 60,000 more expected in September, and with a stated goal of fielding 200,000 low-cost AI-enabled drones by 2027. Gauntlet 2 also raises the bar. More companies, more systems, more realistic operating conditions, including night operations, urban environments, and confined spaces. For the battery industry, the key takeaway is pretty simple. Drones are becoming consumable military hardware like ammunition, more than like traditional aircraft. That changes the demand profile. Instead of small batches of specialty packs, the market starts to require higher volume, lower cost, rapidly replaceable battery systems that can support one-way attack drones, first-person viewer systems, ISR platforms, and other attributable unmanned systems. So using the article's cost targets on per unit, the battery opportunity becomes more material. We internally modeled drone batteries to account for about 15% of unit cost, meaning a $5,000 drone carries $750 of battery content at a pack level. At 200,000 drones, it becomes $150 million. Not that much. But if you put it in the context and scale, Ukraine can produce between an estimated 4 and 8 million drones annually. So you can start to begin to understand what scale does in terms of market opportunity. This is not just one program. It fits into a broader defense shift towards replicator, small UAS, loitering munitions, and Army efforts to treat drones as expendable systems that can be produced and replenished at scale. That creates demand for domestic cells, packs, battery management systems, chargers, field swappable modules, and the supply chains are not dependent on China. The bigger industry implication is that defense drones may become a new demand anchor for US battery manufacturing. The technical requirements are different from EVs or grid storage. Weight, power, discharge rate, ruggedization, safety, storage life, and manufacturability matter more than long cycle life and lowest cost. But the strategic message is clear. As the US scales drone production, battery supply becomes one more constraint and one more opportunity in the domestic defense industrial base. So stepping back, this program should be viewed in the context of a recent $74 billion budget request spent on drones, counter-drone systems, and supporting infrastructure across the defense budget, and managed by a newly consolidated Department of War office. Drone dominance is an early execution signal of the much larger capital cycle. As funding is deployed, it reinforces the shift toward mass-produced autonomous systems and significantly expands long-term demand for batteries across both offensive and defensive drone ecosystems. So one program with many, many, many more in the works. So, and this newly formed office just announced a couple days ago.
Yeah.
So.
Yeah, that's exciting. A couple of things come to mind. First is Defense Department or War Department, whatever they want to call themselves. Deep pockets there, that is never going to change. Mm-hmm. What's different in the past is that, Charlie, you alluded to this before we hit the record button, but it's like a few years ago, you said you sensed much less interest in batteries for drones or for anything in the industry, but now they've become believers. They read the same things that we do and are becoming believers. Is that right?
Yeah, and so what they're looking at, and I think this is like a common theme, be it robots or drones, is that they're looking as batteries as a performance lever, saying we can have the same platform, we will pop a more high performance battery in there, and all of a sudden we have a different kind of vehicle here. So and the same across commercial and military or dual use platforms. You're able to do this. You're able to use these levers and without swapping out 100 other different parts. You can just focus on the battery and have essentially have different products that way. So.
Right. So lots of advantages. Yeah, excellent. Okay, well that leaves it up to me to play to bat cleanup here. While Maria traveled to GM's facility on the West Coast, I was actually in Stuttgart, Germany, attending the battery show, where I heard a lot of interesting information, but a very good keynote from Jennifer Carl, who is a policy officer at the European Commission. And so I will discuss an article I wrote on that very briefly about how Europe is responding specifically to their dependence on China. So it's a serious problem. So Europe spent 27 billion euros on batteries last year, and 87% of that money went to China. And it's not just finished batteries. They're dependent on other countries for critical materials like lithium, nickel, graphite. Nearly 80% of their lithium comes from Chile. So right now they're kind of at China's mercy. So how to respond? So the response, as Ms. Carl outlined, they're doing three big moves. First, they're cutting through the red tape. Through the Net Zero Industry Act, they've created this strategic project designation for major battery facilities. And if you get that status, you're looking at only 9 to 12 months for full approval, not years, months. And they've already designated 30 strategic projects, and 5 of them are battery related. They're also changing how governments buy things. It's not just about lower cost anymore. It has to be sustainability and supply chain resilience as part of the equation now, and that's a big shift. Second, they're getting serious about local content. The Industrial Accelerator Act sets up progressive requirements for what has to be made in Europe. For EVs, it starts with assembly in Europe plus 3 battery components, including cells. And then 3 years later, that jumps to 5 components, adding things like cathode materials and battery management systems. And if you're a foreign company wanting to invest more than 100 million euros, then you need to have over 50% European workforce. And there may be other requirements as well around technology transfers and so on. So they're putting real money behind this. Another response is the battery booster facility, which they're creating, which puts 1.5 billion in interest-free loans on the table, specifically for cell manufacturers trying to scale up. And another 300 million goes toward critical raw materials. So what it means is they're trying to move from being a battery importer to being a manufacturing leader. And they're doing it with this approach: faster permits, local content mandates, and financial de-risking all working together. So this is the reason it's worth mentioning at all, is not only because I had such a swell time in Stuttgart, but also because it's relevant for what the U.S. can do. The U.S. has its own strengths in combating China and so on. Like the U.S. has larger financial firepower. It has the defense authorities that the EU doesn't have. Speaking of defense, they have a strong venture capital ecosystem. So these are things that Europe doesn't have to that extent. But the EU, here they are with faster, more coordinated permitting and clearer component-specific mandates and integrated blending finance. So there are things that that the U.S. can learn from what the EU is doing. I think that is a good time to wrap it up here. It's been another fine month. We will see you in late July or early August to discuss what happened in July. So thank you both very much.
Thank you.